Hi and welcome. In this presentation I will make a short introduction to vehicle technology. So if you are new in this field, this is the place to start. As you know, there are many types of vehicles with different purposes. Every type of vehicle, or even every vehicle model, must be carefully designed for its purpose. Trucks are designed to transport bulky and heavy goods. A premium segment passenger car needs to have an outstanding driving performance. Buses for city traffic might need to comply with strict emission policies, and so on. So, different types of vehicles have different design for various reasons. Still, they are quite similar from a basic technology perspective. Most, if not all, motorized vehicles can be described according to function groups. For example, in this way. An energy converter, which can be an engine or an electric machine. An electrical system, a driveline, brakes, frame, suspension, steering and wheels, and body, cab and interior. Again, different types of vehicles may look different, but on a function group and main component level, the purpose and functions are basically the same. In this course, we will focus on components that belong to the groups energy converter, electrical system, and the driveline. The powertrain is a set of components that propels the vehicle. To the left, you see a simplified view of a rear-wheel drive powertrain, and to the right is a front-wheel drive powertrain. Again, their appearance might be different, but they have the same basic components with same basic functions. In this case, the energy converter are combustion engines, since fuel is burned to produce mechanical work. As you probably know, diesel and gasoline engines are combustion engines and are by far the most common. Therefore, we refer to powertrains with combustion engines as conventional powertrains. However, electric powertrains are becoming increasingly popular. Here we see the chassis and powertrain for a passenger car. Of course, the energy converter is an electric machine with a battery in this case. Here's a view of a conventional truck powertrain. Do you recognize the main components? To see what happens inside the engine, it has been stripped down to the bare pistons, piston rods, and the crankshaft. A mixture of fuel and air is ignited inside the cylinders, and the pressure bursts that follows push the pistons to make the crankshaft rotate. The rest of the powertrain is there to make the best use of this mechanical power. The power of the engine is transmitted into the clutch and through the gearbox. The gearbox transmits the torque and rotational speed to the driveshaft. The driveshaft transmits the torque and rotational speed to the rear axle. The rear axle, with a differential, distributes the power to the wheels. And the wheels, which of course are in contact with the road surface, produce the traction force needed to propel the vehicle. Later in the course, we will return to these components. We will also discuss the basic physical properties, rotational speed, torque, and power. For example, we will describe the engine properties in diagrams like the one you see here. Note that both the engine torque and the engine power varies with the rotational speed. We will discuss this thoroughly and study the implications for the design of the powertrain, for example, with the goal to minimize fuel consumption. That was a short introduction to vehicle technology. Now, and this is important, for the goal of this course, you don't need to know the fine technical details on how the powertrain components are designed. So, if you are new to vehicle technology, don't worry, you will do just fine. Okay, for the remainder of this presentation, I would like to give a short overview of some basic powertrain layouts. Here you can see a schematic description of a conventional powertrain. As already mentioned, these are by far the most common, and we therefore refer to them as conventional powertrains. In general, there are some important classic advantages: long range, fast refueling, and low cost per unit of power. But as you probably know, there are some disadvantages too. Low efficiency, only about 15 to 35%, depending on the type of driving situation. Energy is not recuperated when braking, no regenerative braking. Pollution due to exhaust gases, and noise. The disadvantages with combustion engines might be too much of a problem in current and future traffic or transport situations. Therefore, there is a need for alternatives. Electric powertrains can be the answer for many vehicle types. In an electric vehicle, the engine is replaced by an electric machine plus a battery plus power electronics. The gearbox can also be simplified. And the advantages, they are high efficiency, regenerative braking, and no tailpipe emissions. The disadvantages are shorter range compared to combustion engine powertrains, slow refueling, that is charging of the battery. Battery has a high cost, and battery weight and volume, that is, there is a low energy density. If we replace the conventional powertrain with a fully electric powertrain, we must consider some new disadvantages. So there is still a need for alternatives. Hybrid powertrains can be the answer. That is, we bring the combustion engine back to the design. A serious hybrid is an electric vehicle with a small combustion engine that charges the battery. Advantages are long range, regenerative braking, and low tailpipe emissions. Disadvantages are low efficiency and high system cost. A serious hybrid powertrain addresses some of the disadvantages, both regarding conventional and fully electric powertrains. There are still some disadvantages though. A parallel hybrid is a vehicle that can switch between propulsion from a combustion engine and an electric machine, or use both concurrently. There are some advantages as long range, good overall efficiency, downsizing opportunities, regenerative braking, design similar to conventional vehicles, lower cost compared to serious hybrid vehicle, and low tailpipe emissions. The disadvantages are limited regenerative braking compared to serious hybrid, and high cost compared to conventional vehicle. In summary, there seem to be advantages and disadvantages for any design, which brings me back to what I said earlier. Every type of vehicle, or even every vehicle model, must be carefully designed for its purpose. And, in a nutshell, that's what you will learn in this course. So thank you for listening, and see you soon.